Here we have a student who is standing on the top of the roof of the school. He's frustrated with physics, so he's going to throw his book over the edge. He throws it down with a velocity of 8 meters per second. So what we're going to look for now is if it hits the ground after 2.5 seconds, we're going to try to determine the height of the school. After that, we're going to determine at what velocity it hits his friend who just happened to be asleep on the grass below. Okay, so for part A, all we know is a velocity of 8 meters per second. So we're given a velocity of 8 meters per second, and it's going down. And we're going to say that up is a positive direction. And we have a time of 2.5 seconds. So we need to include our direction here since these are vector values. We know one other thing, however. We know that the acceleration due to gravity also exists, and that's going to be 9.8 meters per second squared, also in the down direction. So we're going to say that up is positive. So we can now do a little bit of math here, solving for d. So we have an equation, d is equal to our initial velocity times time plus 1/2 of our acceleration due to gravity times time squared. Keep in mind that anything that's in the down direction has to be given a negative sign. So this tells us that our v1 is negative 8 meters per second. Time is 2.5 seconds, plus 1/2 of negative 9.8 meters per second squared times time again, which is squared. You're going to plug that all into a calculator. You're going to get a value of negative 12.9 meters. So that's because we're looking downward, right? We can just take the absolute value of this, and we can say that therefore school is 13 meters high. What about part B? So part B is asking us now that he's hit his friend down below. We want to know the velocity right before the textbook stops. So obviously when it hits something, it's going to stop. So we're looking for the velocity right before the instant of impact. We can take our equation, which states that the acceleration is equal to your change in velocity over time. We can rearrange this because we know that our velocity is v2 minus v1. And we can continue to rearrange this until we get a value for v2, which is going to tell us that v2 is equal to v1 plus at, which gives us negative 8 meters per second plus negative 9.8 meters per second squared times your time, which is 2.5 seconds. All of that gives us a v2 value of negative 17.8 meters per second. So because of that negative sign, we'll say, therefore, the final velocity, or the velocity that he hits his friend with, is 17.8 meters per second, and include the direction, which is down. We get that down, again, from this negative sign.